Hello everyone, Mr. Brian here for our third in the Where's Mr. Brian series. And today we're at one of my all-time favorite locations, a place where I spent many a summer's day as a child growing up. And I'll show you where that is here in just a minute after I go over a couple of the activities that we're going to be doing today. Okay, so as you see, as always, I've got my little cauldron with some water in it. And I've got, from what you will have received in the mail and hopefully have put together, your little do-it-yourself wooden boat kit. You can see that we can test that out and that's going to float. But as you guys know, I love to do things on a larger scale. You know, anything worth doing is worth overdoing. And so we're going to test this out at the location where I am today. Another thing you should have received in the mail is a bag here that's got a piece of aluminum foil, and it has 12 of these little pirate plastic coins. And so what I want you guys to do, and what I'm going to do here, is I want you to create some sort of boat or like barge or something that you can have. We want to see how many of the 12 little pirate coins can you fit on your boat before it sinks. Now with mine, I'm going to just do a simple kind of little box of things. Now, some of you may want to test as you're loading up your pirate coins. You may want to do them, you might test and say, okay, what if I had them all on top of each other? Some of you may want to test and line them all up side by side to see if that's something that's going to help. No, that's the fun part of science. We get to try out different ideas to see what it is that will work, and if it doesn't, we will try another thing and see if that works, and just repeat and repeat until we find the desired result. So, another thing you may want to say, okay, like with the box that I'm making, I'm leaving my sides fairly small. Is that going to be beneficial when I move this to a larger scale, or is that going to cause more possibility of sinkage? Will I lose where my coins are wanting to go? So kind of messed around with this enough here. So let's, one, without tearing your boat up, that's why we're using aluminum foil. It's nice and simple to use and easy to kind of piece back together to a point. So let's see here if I can get this thing to float. Okay, so as you can see, my boat floats. That's always very successful. You know, any good sailor would tell you the problem is not when your boat is in the water, it's when the water is in the boat. So far we're doing okay. And so now let's start adding the coins, shall we? So here I've got 12, and I'm not just going to go and throw them down in the boat. That's not going to be very helpful. So I'm going to just drop them in, wait, say, okay, there's one. There's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So as you can see, my simple little design was enough to help keep all 12 of my coins afloat. Now you may want to try this with something heavier, you know, try some random little Lego bits that you may have at home or some minifigures, or you might, you know, intentionally try to sink your boat. But I'm glad that my boat didn't sink yet. So we'll test it again here. But now let's move on to our next activity. All right, so as you guys can see where we are, we're here at the Lake Tansey Resort's outdoor pool, swimming pool here at the Thunderbird. This is one of my favorite places to come as a child growing up. I love to swim, I love being in the water, so this is always a lot of fun. So we're gonna be doing some things here at the pool in and involving the water. And this will be the larger scale place where we will be filming with testing our boats and a couple other fun little things that we'll be doing. And then we'll finish up with another fun material I brought with me. Okay guys, you may remember when we were at the Dewar Soccer Complex, we were launching off our paper air rockets there, demonstrating Newton's third law of motion. For every action there's an equal but opposite reaction. So I've been putting in the air should be pushing down, which should shoot our rockets up and out. I realized that maybe we may not have had a really good sense of scale as far as where the rockets were going. So as you can see, I'm here on one side of the pool and I'm going to shoot them to see if we can get it to go all the way across the pool and see how far else it travels. Now, just like before, I've got it pressurized. I went just around the 25 or so PSI, the top recommended level. I'm gonna count down 3, 2, 1, hit the button, and then we'll cycle through all 4 of our little paper rockets that I have. The first one we have is our little paper rocket that performed the worst of our 4 that we did out there. So I thought, well, let's start with that and see if it fares any better here after a little bit of tape repair, a little TLC, if you will. And so let's see what happens. So here we go. In 3, 2, 1, fire. Well, as you can see, that rocket certainly did the same thing that it did last time, which is exactly what I figured that it would with that style. With how the nose had flattened out, I could really tell that its flight path was not going to be as great as what it could have been. So now I'll get this next one ready and we'll try the other one that has the paper nose cone. Okay, so here we are with our other paper nose cone. Now this one has some hot glue around the edge of it, and it did a much better job than its counterpart did while we were at the soccer complex. So let's see if we managed to make it all the way across the pool this time. So I've got this pressurized just like the other one. So here we go. In 3, 2, 1, fire. Almost. It lacked just a teeny tiny little bit, making it all the way across the pool. So that's awesome. So now let's try our hard-nosed rockets. Okay, so here we've got our first of our hard-nosed rockets. This is the one that has the 2 wings, and it did a pretty good job. I can see that our wings are starting to pop up a little bit, and the body has got a little bit of an issue. So this one may end up performing very much like our first rocket did, but we'll give it a test. So let's see here. So in 3, 2, 1. Again, an almost. If I'd angled it just a little bit slightly off, it would have made it out of the pool. So let's try our last of our hard-nosed rockets. Okay, here's our last of our hard-nosed rockets. This is the one that flew the best for us at the Dewar Soccer Complex. And I'll tell you guys a little bit of a secret with these rockets. All these rockets are 2 years old. I didn't make fresh ones for what we were doing today. Do you think I probably would have had better luck if I'd made brand new rockets? Do you think they would have flown a little bit better? Well, I guess sometime in the future, you know, maybe next summer, we can all be out here and test it out in person and look and see if that ends up being true. So I've got our last rocket here all pressured up and it's ready to go. So let's fire it off here in 3, 2, 1, and fire. Well, as you can see, much like at the Dewar Soccer Complex, this one was the most well-made and one that I probably will still keep since it's the only one that's not wet. And, you know, keep testing this one to see how long will it endure? How long can we continue to use that? So I've got one more thing that I want us to kind of review. Then it's going to be time for us to start testing in the water. Okay guys, here's our last thing that we're going to do before I finally get in the water. We're actually going to test our little do-it-yourself boat and our little pirate boat with the coins in the pool. You know, much larger body of water for us to test in because because that should be a lot of fun. Now, one other thing we're going to test is I wanted to bring back another activity that we've done in the past. So you can see here, I've got a sandwich bag, and see here I've got my pitcher of water. And as usual, what I'm going to do when I do this, we're going to fill the sandwich bag up with water. Remember, as I always say, this would be a great thing for you guys to do outside on one of our hot summer days with a parent or guardian's permission. Our number one important thing to remember when you're doing this is make sure you seal the bag, because otherwise when you go to grab it, it's all going to come whoosh. Now you might be saying, but Mr. Brian, it's a hot summer day. That would feel really good. And you're right. But your parent or guardian may not like that things are getting wet. So make sure that you seal it up. And again, as we have lots of interesting bugs and other creatures outside, remember that as light refracts through this, it acts like a natural magnifying glass. So it's fun to examine and look at things close up. Now, as we've discussed before, our plastic bags, if we looked at them under a microscope, are a bunch of polymer chains of plastic that act as, when you go to poke the pencil through there, which you can see is still nice and dry, it equalizes the pressure as long as you remember to go through both sides of the bag. And just like before, as always when I do this, I've got my 13 pencils, and I'm, as always, purposely trying to get my pencils close together so I can create some drippage and everything. So I guess I'll get the cauldron here just in case. But what we're going to test here is if this works when I have a bag full of water here in another fluid, which of course is air, and this works, will the opposite work? If I take one of these bags and I fill it up with air and I hold it underneath the water of the pool and I poke the pencils through it, will I get the same thing to happen? Now, as you can see, I have managed to pierce my bag close enough like I was hoping, so I've got an unequal amount of pressure around some of these, so the water is starting to drain out. And then of course, as I pull the pencils out, the water will come out like a nice little fountain. As the pressure works to be equalized, then it finds its way out. So is this going to be what happens when we try the opposite of this, when we try the inverse of this, when we have the bag of air under the water? Let's test it and find out. Okay, so I'm now officially in the water. I've got the pencils here, I've got the bag, and I've got a straw. Now this is a pre-wrapped straw, obviously, so I'm going to pull this off. I'm going to get the other end, and we're going to inflate the bag. I'll seal it, then we'll poke the pencils through, and we'll see will the opposite happen. So let me get this other part of the wrapping off, and and one thing, if you're going to try this at home, you want to do is you want to make sure that you seal up the bag everywhere but where the straw is, because otherwise what you're going to end up doing is you're going to be losing all the air that you're trying to put in. So then once you see that you have the bag all inflated, carefully and quickly pull out the straw, seal that last little bit, because just like with the water, we don't want all the air, if you go to squeeze it, it'll go whoosh back out and you're going to have to start over. So here we go. And that looks pretty good. Okay, so I'm going to stop the camera for a minute and we're going to test this out. I'm going to stop it so I can put my straw down on the side of the pool. and pull up. Okay, so as you guys can see underneath there, it was still holding some of it there, so the opposite part of it is true. I've got more pencils than what I typically use. I didn't want to keep going. I do still feel there is still air inside of this. I could have kept going. It's not completely flat or anything, but we're quickly losing daylight, and I want to make sure that we get to our other activities. So that's why I went ahead and I put a stop to this. So next we're going to test out our boats. Okay, so here we are in the pool. You can see I've got our do-it-yourself little boat. It's floated well when we've tested it in our little cauldron. And hopefully you guys, if you've had a kiddie pool or tried it in the bathtub or some other area, that you've had some success. But since I'm at the pool, let's go ahead and see if it'll float here. So in 3, 2, 1, and oh, as you can see, with this much wider amount of body, mine, with how I have the sail done, it's a little bit top heavy and it falls over. Now, just like when we were making it, if we move our rudder around a little bit, let's see if this will help, and let's see if that will distribute the weight a little bit better so that we'll have a better shot of getting it to float again. Oh, as you can see, that time I moved it too much, so it tilted the other way. This is very similar to how you have to work with if you have little canoes or kayaks to try to make sure that you have everything completely balanced. So you can see with the natural movement of, the pool is very much akin to like a lake for a boat this size. So as you can see, it takes just the smallest little bit of a change in position in order to try to get it to float. Now the other thing we're going to run into is we're adding weight to our sail by it getting wet. This little canvas material, that is going to be adding some weight. But again, that's why we wanted to test it. We know that it floats in a smaller area, but in our larger area here, we can see that we are not quite as successful. And so, we've talked about scale models and how scientists will test scale models to see if that's a shape or something that they could use in a full size a material or whatever it is that they'd be looking for. So this would be one that they might want to take back to the drawing board to try again. But that's why I wanted you guys to see this, because I kind of expected this to be the case with this. Now I also have my little aluminum foil boat here. We got to do a little bit of a repair because it kind of got smushed in my hand. And let me just let this float over here for a second. Okay, so here we go. It's floating, so I'm going to add the coins again, just like I did before. I'll try to keep it close here to me. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So all of my coins were able to float without any issue. So I hope you guys had as much success with that as I did. And so I've got one other fun thing to do before we move on to our final material.
Okay, what I have here are some diving rings. Now I wanted to use the diving rings to talk about the 3 types of buoyancy. Now if these diving rings stayed up at the top of the water, if they floated like our aluminum foil boat, then we could say that they are positively buoyant. Now if the diving rings stayed here in the middle part of the water of the pool, and they didn't really float or sink, then we could say that they are neutrally buoyant. But as you can see, all of these diving rings are sinking down to the bottom of the pool. That means that these diving rings are negatively buoyant. So I thought that this would be a fun little activity to show you guys to talk about the 3 types of buoyancy. And now let's move on to our final activity.
Okay guys, so that fun material that I said that I had for us to finish up with things today, it's inside of this cooler down here in some bags. And what this material is inside these bags down here, and it is dry ice. Dry ice is solid carbon dioxide. It's the same stuff that we breathe out. You know, we breathe in because we need the oxygen. When we breathe out, we have carbon dioxide. What's interesting about carbon dioxide is typically it just goes from a solid to a gas. It doesn't involve the liquid stage like what we see with water. You know, water, when it's hot, is steam, and that's its gaseous form. Liquid water, you know, is what we drink every day. And then of course, if you stick it in the freezer, it should freeze and become a solid as ice. So what I have in here in these bags is we have some dry ice. Now, you have to be really careful when you handle this stuff, and I'll cut this out and we will mess around with this here because I'm really looking forward to, for you guys to see what happens with when the dry ice meets the water of the pool. So let's see what happens with that. Alright, do you guys hear this? That screaming is the metal vibrating super fast because of how cold the dry ice is. This is not something you want to handle with your own hands. This is something that you want to have either gloves or, like I have, you have a pair of tongs. This is definitely something that you do not need to do yourself. This should be something that should only be done by a parent or guardian, or really, we're also handled by someone that is used to handling materials like this, like I am. And so, watch what happens when I throw this into the pool here. As you can see, we have a lot of bubbles coming up out from the bottom of the pool. This is all the carbon dioxide being released as bubbles as it bubbles up to the surface. This is very much akin to if you've had some Halloween parties or other parties. It's how movie theaters or movie studios can make a nice big fog effect with a fog machine if they don't use liquid fog. It's really easy to use a whole lot of dry ice in order to get the same effect. And here in just a minute, I'll try to show you what this looks like from under the water. But before I do that, I'm going to toss more of the dry ice that I have into the water, and we'll do this part on the deep end of the pool. Okay, where we are now is in my favorite spot of the pool. This is the deepest part. The deep part here, it goes to 9 feet deep. And what's neat here is when I toss in the dry ice, not only is it going to take a while to get to the bottom, but it also takes a while for the carbon dioxide bubbles to come back up. So you guys just keep watching, and you'll see as I add more and more dry ice into the pool, we'll start to see more and more bubbles come rising up from the bottom.
Okay, as I continue to throw dry ice into the pool, I would again like you to pay close attention to how here on the deeper end of the pool, it is taking a longer period of time for the carbon dioxide filled bubbles to break on the surface of the water than what it did in the shallow end of the pool. And while it is very interesting, watching as the bubble breaks, it kind of makes it look like that the water is boiling, even though that it is not. I was curious, what does this look like from underneath the water? So now, let's take a look at some footage that shows just that. As you can see, it has unfortunately gotten too dark here at the Lake Tansey Outdoor Pool to show you a clear view of the underwater perspective of the dry ice in water reaction. So, let's try this again at another location. So thankfully, a co-worker was able to grant me access to another pool, and as you can see, we have a much better view of the underwater perspective of the dry ice and water reaction. Now, you'll also notice that I have tossed dry ice into different depths of the pool, And as I slow this footage down, I would like for you to notice how we can really see the trapped carbon dioxide gas in the bubbles as they rise up to the surface of the water, where, of course, when the bubbles break, they release that trapped carbon dioxide gas, which produces that fun boiling effect that we noticed earlier. So I hope that you've enjoyed looking at this unusual perspective of this fun experiment, and I've got one other fun bit of footage to share with you. In the last part of this video, you will see that I was allowed to toss my remaining dry ice into their hot tub. Now this is exciting because this is something that I've never done before, and I was curious to see how the reaction would be different in the water of the hot tub than what we saw in the reaction in the water of the main pool. Now as you can see, the reaction is happening much more rapidly in the water in the hot tub than what we saw in the water in the main pool. In fact, it looks like the jets are actually on in the hot tub. We're seeing so many bubbles, while all the jets are actually turned off. All the bubbles and everything that we see are just coming from the reaction of the dry ice changing from solid carbon dioxide into the gaseous carbon dioxide that we see released in a much thicker carbon dioxide fog at the surface of the water here in the hot tub. Now, the reason why we're seeing a much more rapid reaction is the temperature of the water. The temperature of the water in the hot tub is 102 degrees Fahrenheit, while the temperature of the water in the main pool was only 82 degrees Fahrenheit. So the much higher temperature produces a much more rapid reaction. Now I hope you guys have enjoyed this video. Be sure to watch to the very end of the video for some picture clues to where I will be in the next episode of the ongoing Where is Mr. Brian video series, and I look forward to seeing you guys in the next video.